Math Blast 25, two-step word problems. The cafeteria had 80 peaches. For lunch, they handed out 40 peaches to students and decided to use the rest to make pies. If each pie takes 5 peaches, how many pies could they make? Well, for this problem, the first step I know is to take the number of peaches, 80, and subtract the 40 that were handed out to find out how many were left. I'm going to look at this in unit form. I know 80 is 8 tens, and 40 is 4 tens. So when I take 8 tens and subtract 4 tens, I still have 4 tens. So 40 peaches, 4 tens is 40, right? 40 peaches are left. Now we're not finished, that was just step 1. Step 2 would be to take those 40 peaches, and it says that the peaches that were left were used to make pies. If each pie takes 5 peaches, how many pies could they make? So I'm going to take the 40 peaches that are left and divide those into groups of 5, because 5 peaches it takes 5 peaches to make the pie. So I'm going to use an array to help with solving this problem. I'm going to put 5 X's representing 5 peaches in each row. And each one of those rows then would represent the pie that is able to be made from those peaches. I can use my skip counting technique to help as I'm building my array as well. Let's just stop for a minute and check. I have 5, 10, 15, 20, 25, 30, 35. It would take another 5 to be at 40, so I'm going to draw one more row of 5. Now I see I have 1, 2, 3, 4, 5, 6, 7, 8 groups, which represents the 8 pies that could be made. So I'll make the statement here, 8 pies can be made. And that's my final answer. Whole numbers as fractions. Use the model to write a fraction for one whole. Well, I notice that the whole is broken into 4 equal parts, so the units would be fourths. And to represent the whole, we would need all 4 of those 4 equal parts. So 4 fourths is equal to 1. Write a fraction equivalent to 2. Keep in mind this word equivalent here means equal. So if 4 fourths is equal to 1, I would need another 4 fourths to be 2. 4 fourths and 4 fourths is 8 fourths. Comparing fractions. Compare the fractions using greater than, less than, or equal. Justify using the fraction models. Here I have 1/8 versus 1/3. I notice that the number of pieces that I'm going to shade will be the same in each model. It is the units that will be different. I will have eighths in my first model, so I want to draw 8 equal parts. Again, I'm going to shade one of those 8, and then in the second model I have thirds, and I'm going to shade one of those thirds. So 3 equal parts, shade in one of those. So as I said, the number of pieces we have shaded are the same because the numerators are the same. It's the size of those pieces that are different. When I have a denominator of 8 representing eighths as my unit, then I'm going to have more pieces, which means each piece will be smaller than when I have a denominator of 3 representing units of thirds. Think of it as a candy bar. Both of these are candy bars. I break one into 8 pieces and you get one of those pieces versus this candy bar broken into 3 pieces. There are less pieces, but the pieces are bigger, so you're likely to want one of those pieces instead. 1/8 is less than 1/3. Here we have common denominators, so our units are going to be the same. In other words, the sizes of our pieces will be the same. Each whole will be broken into sixths here. I'm going to make 6 equal pieces in the holes. This time I want 2 shaded, and in this one I want 4 shaded. when my units are the same, I'm just comparing how many I have of those units. So 2 is less than 4. Therefore, 2/6 is less than 4/6. Line plots. Ryan measured Legos and recorded the data below. The line plot starts at the 3-inch mark. Use X's to show the data. So if Lego A is at 3 2/4 inches, I want to go to 3 2/4 and put an X above it. Lego B is at 5 inches. Lego C is 4 1/4 inch. And Lego D is 4 3/4 inches. Notice each Lego had its own measurement with no two Legos measuring the same. Now, had we had the case where maybe say we had a Lego E and it measured the same as Lego D, 4 3/4 inches, then I would go to 4 3/4 and I would put a second X above the first X. When we have line plots, we stack our X's for multiple forms of the same piece of data. In this case, that doesn't happen. Area, unit squares. Determine the area of the shape. The area is the amount of space that covers the two-dimensional figure here. So I can count each of the squares to figure out the area of our larger square here. I see that there are 16 squares. So the area is 16 square units. Now, without counting the squares, I could also figure out the area by saying, well, this side is 4 units, and this side is 4 units. And to find area of any rectangular figure, we would take our length and width and multiply those together. So I could take the 4 units times 4 units and get 16 square units as the area.